Yeah, welcome to Easy Mathematics and a new video, Digging for Gold, or with the subtitle Hidden P, the Golden Ratio. Yeah, what is our plan? I want to talk about two topics. The first one, the ratio of tangent segments. Now, first we specify the configuration, then we explain the goal. After that, we make a plan how to correct this, and then we take a look into the solution. And the second, we talk about Yin Yang, and we play the same game. Alright? The calculations are very elementary, so I will not go through all details, okay? Alright, ratio of tangent segments. So the configuration is like that. We consider the intersection point t, xp, yp of the functions tangent x and cosine x in the open interval 0 to pi over 2. Let A be the intersection point of the tangent line T10 on f through P and the x-axis, and let B be the intersection point of the tangent line T cos on V through P and the x-axis. Okay, so we take a look into the picture. So here we see the cosine function and the red tangent line T cos. It intersects the x-axis in point P. And here is the tangent function and the blue tangent through P, and it intersects the x-axis in point A. Yeah, and what we wanna calculate is the ratio BP over AP. Yeah, and as you can guess, this is the golden ratio. Because the video is about hidden P. So BP is this line segment, here the red line segment, over the blue line segment, okay? And this is phi. Alright, we make a plan how to calculate this. So if you draw a picture, then you will see the first, the first step is we determine P, then we calculate the gradient m tan of t tan, and then we take a look of the 0 to get the point A. We play the same game for the cosine function to get point B. Then we calculate the length of BP and AP. Yeah, and finally we get the ratio. Alright? Okay. Determine P. Yeah, to get P, because it's the intersection point in the open interval from the intersection of the cosine function and the tangent function. Yeah, we set them equal. So cosine equals tangent, and tangent is sine over cosine. We bring this cosine in the denominator to the other side to get cosine squared equals sine, and with the Pythagorean theorem we get sine squared plus sine minus 1 equals 0. Okay? So this is a quadratic equation in sine, so we can use the PQ formula for this equation, and we get minus 1 plus minus 1 squared minus and so on, and the final result after simplification is minus 1 plus minus square root 5 over 2. So x, we can use the arcsine on both sides, so xp is arcsine square root 5 minus 1 over 2, and this is arcsine of 1 over the golden ratio. Alright? Here we take the plus sign. What about the minus sign? The other root is sine x less than minus 1, and we know the real sine function is between minus 1 and plus 1, okay? So this is our unique solution as we expected. Alright, now we are ready Now we are ready to take care of the gradient of the tangent line through p on the tangent function. Okay. Yeah, the derivative of the tangent function, you know, it can be written as secant squared. You can also write it as 1 over cosine squared, and a better way for our purpose is 1 over 1 minus sine squared. Why? Yeah, because now we can evaluate the derivative at xp, and this is an arcsine, so it makes sense to use the derivative of the form 1 over 1 minus sine squared, so the arcsine and sine, it cancels out, and we get 1 minus 1 over pi quantity squared, and if we simplify that, we get the golden ratio pi. How beautiful is that? Okay, the third point on our plan was the zero of the tangent line to get the point A, and yeah, we set up the equation of the tangent line y equals m x minus xp plus yp. Yp is tangent of xp. Okay, and to get the zero, we set this equation 0. So we solve this equation for x to get xa, and after plugging in all the values we have, it's an exercise for you. We get arcsine 1 over pi minus the square root of the square root 5 minus 2. Okay, so I leave that as an exercise for you. We play the same game for the gradient of the tangent line on the cosine function. The derivative is already a sine function, negative sine of x. We plug in xp. This gives us minus 1 over pi, and this is, if we take a closer look, this is minus 1 over the gradient of the tangent line through the tangent function. And you know what this means. We make an observation. T tan and t cos are perpendicular. It's just a nice observation. In other words, our triangle ABP is a right triangle. How beautiful is that? Yeah, the zero of the tangent line, we play the same game. We set up the equation of the tangent line. We set this equation equal to 0. We solve for x to get xp. After plugging in all the values, also here we leave that as an exercise for you, we get arcsine 1 over pi minus square root 2 over 2 times square root of square root 5 plus 1. Alright? Yeah, and now we are ready to take care of the length of BP. And you know the length of BP, we use the Pythagorean theorem, xp minus xp quantity squared plus yp minus yp quantity squared. We plug in all the values to get this. So the arcsine, it cancels out. All we left are here square root 2 over 2 times the square root quantity squared minus 1 over pi square root of this quantity squared, and after some simplification you will get square root of 5. And yeah, I left here the squared because I do not want to use the square root here. It makes, yeah, it looks messy to use the square root here, so I left it as a squared. Okay. Yeah, we play the same game for an AP. We plug in the values. Also here the arcsine cancel out, and what we are left is 3 times square root 5 minus 5 over 2. And if you like, it's not necessary, if you like, we can write it as 5 plus square root 5 minus 3. No, if you like, you can write it like that. Not necessary. And now we can take care of the final ratio. BP over AP, we write that as BP squared over AP squared because we have the squared values. Then we take the square root. Then we plug in the values and we simplify that. we get square root 5 plus 3 over 2. And now you can easily see that this is the square root of 1 plus 5. Can we simplify that? Yes, we can, because pi solves this quadratic equation. We see that 1 plus pi is equal to pi squared, and because we are talking about length, these are positive, so square root of pi squared is pi. To make a summary, we have reached our goal. bp over ap is pi. Very beautiful result in my opinion. And now we take care of the yin and yang. And I show the picture and then we talk about that. So here is the picture. So if we draw here two lines, so think of that like that. The big circle, the center of the big circle, is in the origin of an xy coordinate system, and the red and orange line, it starts at the x-axis and it hits the midpoints of the white or the black circle. And if we intersect these arcs, half circle arcs, then the length of the red one is pi, and the line of the orange is pi to the power minus 1. How beautiful is that? We can find pi in the yin and yang, and so we set up our configuration. We need some length. I call the points A, B, C, D, E, F. C is the midpoint of the black circle, F is the midpoint of the white circle, E is the intersection point, and so on. This is our setup, and what we want is, because we are free in choosing our length, so we are just talking about scaling. So we say let A be equals 1, and what we want is we want AD, so the whole red one, and we want AD, this one. Alright? And now we make our plan, and when we see the picture, we will need the Pythagorean theorem, of course, and we see that BC is CE is BF is AB over 2 is 1/2. Okay, so if we take a look at the picture, it's clear that BC is half AB, and CE is also BC, and BC is also BF, and so on. Okay, this is easy to see. And the solution is also very clear. So AE is AC plus CE. So if we take a look at the picture, AE is AC plus CE. Okay, and now you can check by yourself. We use the Pythagorean theorem. For AC, this is AB squared plus BC squared, square root. CE is AB over half. BC is AB over half. And now we know BC is CE, BE is BF is AB over 2, this is 1/2. If we plug in all the values, we find AB times square root 5 over 4 plus 1/2, and if you simplify that, we get pi, and our setup was AB equals 1, so AE is pi. Very beautiful. And the same, AD is AF minus DF. So AD is AF minus FD. And also here AF is AE and DF is 2 times CE. We can write it also as in this form. So take a look at the picture and make this clear for yourself. Yeah, and CE is 1/2 and AE, we have already calculated AE, this is phi, and 2CE is 1, so we get phi minus 1, and also here because phi solves the equation x squared minus x minus 1. Phi minus 1 is 1 over phi, or phi inverse, so phi to the power minus 1. The reciprocal, I should say, not inverse, pardon. Yeah, phi to the power minus 1. And how cool is that? The golden ratio in the Yin Yang, very beautiful. Yeah, that's all for this today. Maybe I plan a second part to this video. I'm not sure right now, but if I make a second part, I have already a plan for the next topic. It's called pi with phi. So this is my plan. I'm not sure if I do it. Let's see. Yeah, thanks for watching. See you next time. Bye bye.